Okay, Math 4 exam review, Chapter 4, problem number 1. Chapter 4 is on systems of equations, and we're going to solve this system by graphing. We're lucky that they have already set these up in slope-intercept form, so it makes the graphing really easy for us. On the first equation, my slope is 5, and remember when we're graphing, we want our slope to be a fraction, and my y-intercept, which we call b, is negative 3. On my second equation, my slope is negative 4 over 1, and my y-intercept is 6. And remember, if our slope is positive 5 over 1, we could also use negative 5 over negative 1, or if it's negative 4 over 1, we could use positive 4 over negative 1 if we don't have space on our coordinate plane that we're given to graph on to go in the direction that we normally would for our slope. You can always do the opposite in both the numerator and the denominator. Okay, we're going to see how good a job I can do here without a coordinate plane drawn for me. I'm going to guess it's not going to be great. Keep in mind that when you're graphing, looking for a point of intersection, it's really difficult if you don't graph really well, and I'm sure we're going to see it on here in a minute, that it's difficult to figure out what your point of intersection is if you don't have a grid with lines all the way through it, which of course on the test, if you have one of these, you'll be provided with a grid to graph on. You won't be having to draw one like I have to do here. Okay, so I'm going to start with the first equation and with my y-intercept because that's always our starting point, and that's negative 3. So there's negative 3 on the y-axis. My slope is 5 over 1, so I rise 5. That's 1, 2, 3, 4, 5. And I run 1. If you want your graph to be more accurate, do it a second time. Rise 1, 2, 3, 4, 5, and run 1 more. And so let's see how good a job I can do here of drawing that line. Not awful. Not perfect, but not awful. Okay, so my second one, my y-intercept is 6. 1, 2, 3, 4, 5, 6. And my slope is negative 4 over 1. That means I go down 4 instead of up 4. 1, 2, 3, 4, and oh, look how lucky we are. We happen to already find our point of intersection. Whoops. We're pretending I've drawn a straight line here. And of course, that right there is our point of intersection, and that appears to be the point 1. I went over 1 and up 2 to get there. So 1, 2 should be my point of intersection of those two graphs. So because my graph is so inaccurately drawn, I'm going to go ahead and check to see that that really is the solution. You, of course, can put both of these in your y equals in your calculator and then do your second function calc, which is under trace, so second trace, and then intersection. Excuse me, or intersect, and it'll give it to you. You can check that way. I'm going to check the old-fashioned way, plugging in. So I'm first going to plug into this one. That gives me 2 equals 5 times 1 minus 3. 5 times 1 is 5 minus 3 is 2. It checked in the first equation. So I'm going to go to the second equation. I have 2 equals negative 4 times 1 plus 6. That gives me 2 equals negative 4 plus 6, which of course gives me 2 equals 2. It checked in both of them, so that means I did a pretty good job of finding the solution, even though my graph was not the prettiest one you'll ever see. Okay, for number 2, our instructions say solve the system by either addition or substitution. So I'm going to look and see which each one lends itself to better, and then I'll pick the method that I think it lends itself to. But you, of course, can choose either method that you want based on what your preference is or what you think it's set up for. When I look at A, since the second one is already solved for y, I'm going to choose substitution. So that means I'm going to take what this equation says y equals and put it in that y. If y equals this, I can replace y. So I have 2x minus 3 times 4x minus 4 equals negative 18. And if you notice, now I have just one variable, and it's really simple for us to solve an equation in one variable. So I'm going to do that. I have 2x minus 12x, distributing my negative 3, plus 12 equals negative 18. 2x minus 12x is negative 10x plus 12 equals negative 18. Now I'm going to subtract the 12 over, and that gives me negative 10x equals negative 30. That was negative 18 minus 12. Divide by negative 10, and x equals 3. Okay, so I have found the x-coordinate of the ordered pair that I need. I have not yet found the y-coordinate. So I'm going to take what it says x is and substitute a second time into this equation. Or I'm not substituting into the same equation. I'm substituting this time into this equation. So I have y equals 4 times 3 minus 4. That's 12 minus 4. That gives me y equals 8. But remember, I want your answer always to be as an ordered pair, meaning 3, 8. I'm going to box that off so you can see it. That's the solution, because I want you to remember that regardless how we're solving these equations, what we're looking for is the place where the two lines cross each other in a coordinate plane. That means it's an ordered pair, or the point that is on both of the lines. Okay, so you can think of this, we just finished solving using graphing. Now we're solving on this one with substitution, but both ways what I'm looking for is the place where two lines cross, or the xy coordinate that works for both of my linear equations. So my first one is 3, 8, and I solved that using substitution. Now for my second one here, because they're both in ax plus by equals c form, I'm going to use addition. But I can't just add the two equations, because if I do, I've got 4x plus 6y equals 0, and I still have two variables. I need to get rid of one of my variables. So I need to have the same number with opposite signs either in front of my x's or else in front of my y's. So I'm going to choose to multiply the top equation by negative 2, and then I'll have negative 4y here and positive 4y here. I could also, instead of choosing negative 2, have chosen negative 3, and then I would have had negative 3x and positive 3x. That's your choice. I just went with making the y's the same. So that's negative 2 is going to be multiplied by the whole equation, which gives me negative 2x minus 4y equals 1. I have 3x plus 4y. What did I do wrong here? Do you notice what I just did there? I said negative 2 times 1 is 1, and that should have, of course, been negative 2. Let's see if I can change that. Don't make that same mistake I just made. You're multiplying through by the whole equation. Okay, fortunately I noticed that, and we're not going to end up with a wrong answer. Okay, so now you can see I have a negative and a positive 4y. They, of course, cancel each other out. Negative 2x plus 3x is x, because remember, now I am adding those two equations. I get x equals negative 3. So I have the x value, I still need the y value, so I'm going to pick one of those two equations to plug x into. Not quite as nice over here where it was already solved for y, but that's okay. I'm going to choose the top equation to plug into, so that's going to give me negative 3 in place of x plus 2y equals 1, and now I'm solving for y, so I add the 3 over, and I have 2y equals 4, divide by the 2, and y equals 2. So again, I want to know that you understand this is an ordered pair. It's the point where two lines cross each other, or the point that is a solution to both of the equations. So my answer is negative 3, 2. So we have now solved by graphing, where I looked where the two intersected each other, and that was my solution. I solved by substitution, because one of my equations was already solved for one of the variables, and then I solved by elimination using addition. I multiplied one of the equations by a number that would allow me to have the same number but opposite signs in front of my variable. So solved 3 different ways. All 3 were solving for the same thing, the point where two lines crossed each other.